Good afternoon, everyone. Welcome to November's First Friday webinar. My name is Claire Murphy. I'm the Education Specialist for ISPE, and I'll be your moderator today. Our topic this month is Sustainability and Resiliency, Climate Change, Drought, and Floods, and our speaker is Tricia Hatley. Tricia is serving as President of NSPE for the 2020-2021 term. As an NSPE member since 1993, she has served in several leadership roles at the chapter, state, and national levels, including President of the National Education Foundation and President of the Texas Society of Professional Engineers. She has a Bachelor of Science degree in Civil Engineering from Oklahoma State University. Professionally, she is a Principal and Vice President at Fries & Nichols Incorporated, an engineering, architectural, and environmental firm with offices throughout the South and Southeast. She has been with Fries & Nichols for 27 years and is the firm's division manager over offices in Oklahoma City and Tulsa. Just a reminder to everybody today, the quiz and handouts will be found on the usual web page. Once we get going, I will be linking that page again in the chat box. If you have any questions at any time throughout the presentation, you can type it into the questions box and we will answer those at the end. And with that, I will hand it over to Tricia.
Great, thank you so much. Thank you for having me here today. And this is one of my favorite things to talk about, and so I'm excited to be with you all today. I want to tell you just a little bit more about my background, just because it kind of sets the stage for how I'm going to frame up the conversation today. As Claire mentioned, I'm a civil engineer by education. While I was going to school at Oklahoma State, I worked for 2 years with the Oklahoma Department of Transportation as a student, and so I learned a lot about the transportation design while working for them for those 2 years. But when I graduated, I went to work for Fries & Nichols, and I have been at Fries & Nichols ever since. I started with the firm as a structural engineer. I worked in the structural department for 2 years and designed all kinds of different structures. Fries & Nichols works for public entities, so we do city, county, state, federal type work. So I design structures for treatment plants and bridges and retaining walls and all kinds of random things. But after a couple of years, I decided I wanted to move over into more into the general civil area. And so for the rest of my career, I've worked on a lot of different things. When people ask me what my specialty is, I say transportation because that's what I'm most comfortable with. I've done a lot of roadway design over the years, both for cities, counties, and state. But along the way, I also got to work on stormwater projects, some water, wastewater, general civil type things, all kinds of different things. And so I say all that as kind of a preface for the conversation today. I'm probably what you would call a generalist in the civil engineering world. So what I'm going to do today is talk about sustainability and resiliency, but in the context of kind of the big picture. My goals and my objectives today are not to give you a bunch of technical data or teach you how to design something more sustainably, but it's more to get you to think about how you can incorporate sustainable design concepts into your projects, how you can think about the issues of resiliency when you're planning your projects and working with your clients or your organization. So that's really kind of the context of the conversation today. So I'm going to do a little bit of introduction, then we're going to talk about why planning is so important in this context of sustainability and resiliency. I'm going to give you an example from my home state where I live now, Oklahoma, on water and flood planning, and then we're going to talk about kind of what your takeaways are from here. So let's start off with definitions. Sustainability has lots of different definitions. This is my favorite, and it's to meet the needs of the present without compromising the ability of future generations to meet their own needs. To me, that has always been very meaningful. But when we talk about sustainability, we quite often talk about the triple bottom line, and that being the intersection of social, environmental, and economic issues, and really incorporating those three components and those three issues into our design decisions. Now, however, resiliency is a little different. Where I live in Oklahoma, we're plagued by tornadoes. I think you guys probably experience that from time to time too. And so, so when we say the word resiliency around my parts here, and we think of tornadoes, wildfires, floods, those kinds of natural disasters. And so we think about FEMA. And the FEMA definition of resiliency is the ability to recover from or adjust to misfortune or change. And here's a little bit more about the FEMA definition. They're looking for communities to proactively protect themselves against hazards. And the Corps of Engineers has this definition. They outline the 4 principles that I'm going to talk about: prepare, absorb, recover, and adapt. And then you have a couple more definitions here. But the kind of the summary of that is that resilient communities proactively build self-sufficiency for rapid recovery. So as you can see, there is a difference between sustainability and resiliency, but they are definitely concepts that are tied together. So as I mentioned, from that Corps of Engineer definition, a resilient community is one that can do these 4 things: and that prepare the best you can, absorb disasters and emergencies when they do happen, recover quickly, and adapt your plan. So one of the things that we talk about when we get into the subject of sustainability and resiliency is climate change. And climate change is kind of interesting because there's a lot of data out there based on science, and there's a lot of models showing different things. So clearly not all the models are correct. So how do we manage this uncertainty? If the science is not certain, not absolute, how do we manage that uncertainty and use that in our planning and design? Well, I think it's critical that we start by thinking ahead and by actually doing planning, having plans in place so that action can be taken quickly when necessary. One of the ways that our communities plan is through a process called comprehensive planning. Part of my time here at Friesen Nichols, I had the opportunity to oversee what we call our urban planning and design group. So our urban planners reported up through me, and they work for cities and they do comprehensive plans. And a comprehensive plan includes the standard elements that you see on the slide there. It's a great way for cities to kind of think about where they're at today and what their infrastructure systems look like, what their land uses, population projections look like, and where they want to go in the future, and what they need in order to get there, and get the buy-in from their community on the improvements and investments that are needed. So those were traditionally what's in a comprehensive plan. And nowadays, today, we're seeing some additional elements being added to those comprehensive plans. Things like looking at energy needs, healthy communities. How do I create opportunities for healthy lifestyles in my community? And disaster planning and resiliency, and sustainability. These are becoming very important components and are included in most comp plans now. And what's most important about that is, and the reason why they're being included is because society, our communities, and especially the younger generation are demanding that an emphasis be put on these very things. And they're using these things to decide where they want to live and what community they choose to set down roots in, and where they want to live and where they want to work. So planning for that next generation is important, and not just to us as humans and people, but it's important to our communities for their survival. So I want to share an example of planning and kind of get you thinking about the impacts of climate change. And so we're going to talk a little bit about droughts and floods and water planning. So and what I'm going to talk about here is how you prepare for droughts, how you plan for floods, how you absorb the impacts, and how you recover and adapt. And I'm going to use an example from, like I said, my home state here, Oklahoma. So as you can see from this chart, climate variability is real. Swings happen. If you look historically, it happens. You don't know when a drought or a flood is coming, but you do know that it is coming. So this graph here on the screen shows Oklahoma's precipitation history since the modern era of recording the data. And the diamonds, little black diamonds, represent the average of the measured precipitation in the region each year. And then the green and the brown traces represent the 5-year weighted average of the precipitation values over time. So you can see there are wild swings in that precipitation, and there are clearly periods of dry periods, and wetter periods as we go through history. And to kind of drill in a little closer, let's look at a recent example. This is a map of Oklahoma in 2010. And this is the drought monitor map that we use. And you can see there's no colors on the map. So that means that everything's clear. There's no drought present in the state. Our water supplies were looking great in 2010, April of 2010. But a short year and a half later, in October of 2011, this is what the map looked like. And in this short time, nearly 70% of the state is in the worst possible drought we could have, and not a single county in the state was immune from some state of drought. The entire state was suffering. That was just in a short year and a half time swing. And then if you look at it today, or I guess yesterday, I pulled the map yesterday, and this is what Oklahoma looks like. You can see now it's kind of a mixed bag. The eastern part of the state is in good shape. The western part of our state is experiencing some mild to extreme drought, depending on the exact location. So these climate cycles are constantly happening, and they represent a challenge for our leaders who are responsible for planning efforts, and for engineers who deal with the projects that come from these planning efforts. The specific challenge here is what water planners often deem the hydrological cycle, and we'll talk a little bit more about that in a second. And this, if you're interested, this is what the drought outlook looks like for our entire country. We're apparently in a La Nina event that's currently underway, which favors increased odds for below normal precipitation over parts of the southern and central thirds of the western U.S. So you can see what you have in store for you here in Illinois as well. So why and how does water planning overlap with flood planning? Regional water planning is largely focused on preparing for and protecting against drought, these situations where we don't have enough water. And regional flood planning is largely focused on planning for and mitigating against flood, these times when we have too much water. So this is what I mentioned is what we like to call the hydrological cycle. And so I'll explain these little charts. If you start at the one on the left at the top, you know, this guy is complacent, you know, everything's fine, no worries. And then things start to dry out, kind of like, you know, the situation Oklahoma's in today, especially the western part of the state. Things are starting to get a little dry, and people are going to start getting a little bit worried, wondering, maybe I ought to be paying attention to that. And then things get really dry. Water supplies start drying up. People start to panic a little bit. You know, where's the water going to come from? Am I going to have enough water to water my grass? What do our water supplies look like? And then it rains. And then they don't care anymore. The concern goes away. And the same thing happens on the flood side. We get a little rain. People start to notice the creeks are rising, the lake levels are high, that kind of thing. Get more rain. We have flooding events. People get nervous, scared. Why aren't we master planning? Where's the money for stormwater? What's going on? And then it dries out again, and the concern goes away. And these cycles happen over and over and over again as time goes on. So it's important for us that are involved in planning infrastructure to have a game plan, and to really stress the importance of long-range planning, and not just looking at what's happening today or what happened yesterday or what's going to happen tomorrow, but really looking out for the long term. Planning is an activity that we have to constantly do. We need to be ready so that we can absorb, recover, and adapt, as we talked about. But the plan also has to be flexible. It needs to have contingency plan. And we need to have a contingency for what happens if the climate swings one way or the other. If things happen, if the event is more extreme than what we thought it was going to be, if we lose a supply. In my area in Oklahoma and North Texas, we have a problem with zebra mussels in our water supply. And we can have a reservoir full of water, but if these zebra mussels and get hold in our pipelines and our systems, they can knock out a complete water supply out of our system and cause a problem. And so then we have to have contingency plans in place to deal with these issues so that we can have the resiliency we need to have as a community to bounce back. So I want to share a quick case study with you from the city of Wichita Falls. Wichita Falls is a city in Texas. It's about 15 minutes south of the Oklahoma border on the western side of the state. And I think this case study kind of illustrates the importance of planning for future growth and the unknowns of drought and floods. So this is what Wichita Falls looked like in 2010. And the main reservoirs looked like this. They were full. Water supplies were in good shape. Everybody was happy, no concerns. And then things started to dry out. In the period of a couple of years, 2011 to 2013, lake levels started to go down very quickly. The drought continued on. Things started to look more like what you see in this picture here. And I can assure you that panic mode started happening. That hydrological cycle I showed you, people were definitely concerned. It was time to absorb the situation and adapt. They needed an emergency plan and actions that could be implemented quickly. And it's interesting, one of the emergency plans that they put into place was to develop a large water reuse project. And this water reuse project included a long-term project, but also a short-term project that included direct potable reuse, and it was with lines running along the ground and on the surface to get them done as quickly as possible so that the residents didn't run out of water. It was that close to happening. And then just 2 years later, we have Wichita Falls in 2015, major flood event. Flooding across the city led to a FEMA emergency situation. So this highlights why you not only need a plan for sustaining a community through drought, but also when the pendulum swings the other way and the rains come. So this is a look at a flood map and the Friday before Memorial Day 2015 in Wichita Falls. The Wichita River was expected to crest as high as 30 feet, 6 feet above the existing record, 6 feet higher than any recorded flood events. And so they didn't know, they had no data, as hadn't happened before, so they did not know where the flooding was going to occur, what parts of the city were going to be inundated. So they turned to Friesen Nichols. We had done a stormwater master plan for them, and so we had some flood models for their city and GIS mapping. And so we helped them absorb this situation by creating an emergency floodplain delineation and maps that they could use to alert their residents and evacuate their neighborhoods. This helped them to adapt to the situation, recover, and prepare for future floods later by refining the maps with more detailed study. So another example that we can talk about is our hurricanes. Climate research predicts that we're going to have larger, more powerful storms. Hurricanes draw energy from that warm ocean water. So I'm sure many of you have read about climate change and you've seen the very active hurricane season that we've had this year. You know kind of what's expected to come here with these warmer ocean waters, larger hurricanes. And in 2017, we had Hurricane Harvey hit the Gulf Coast. And this little video is going to run, this starts on August the 25th, and it's going to run over a period of 5 days and show you Hurricane Harvey hitting, and then the second hurricane that hit behind it. And you can see how it just sits over the greater Houston area of Texas, spins around and twirls around, just keeps dropping rain. We're on day 2 now. It's still raining in the Houston area and the upstream areas. Just continuing to go. Now we're day 3. And the rain is still falling in the Houston area, record level rains, just flooding the whole area. Day 4, still raining. And it continues into a 5th day here, and more activity. It was just an incredible, amazing, historic event that happened in the Houston area and really that whole area of the Gulf Coast. So I'll show you a little bit here what the rainfall totals look like. This chart shows the average 5-day rainfall over a 10,000 square mile area from the largest storms in history in the continental U.S. Until Harvey, the largest storms in the last 120 years had been between 18 and 21 inches in 5 days, averaged over this 10,000 square miles. Harvey had almost 35 inches over 5 days. So this kind of storm event is what we're challenged to prepare for as we move forward. So how do we go about addressing things like this in our communities? So this is the model that I'll propose that we kind of talk through, and prevention, informing, maintenance, reducing, and this is all kind of centered around the topic of flood risk. So in the area of prevention, one way to look at this is to think about different ways that we can grow our community so that we can minimize impact. We want to be a leader. We would like for our communities to lead in this area, have good criteria and policy in place, have high standards, that will provide effective options to reducing runoff in our communities. So these are big ideas, but there are simple approaches that will have an impact on our communities. Things such as collecting rainwater, having rain barrel programs and incentives for our communities to collect rainwater and reuse that water. Things like allowing permeable pavement where possible in our communities. Encouraging the use of native plantings that don't require a lot of water usage. These kinds of things are important for our communities in this effort. It's often called, in our world, I call it, in the world I practice in, I call it low impact design, LID. I'm sure many of you have heard of this. The concept is to minimize the quantity of runoff while maximizing the quality of the runoff. And so here are some examples of what LID implementation looks like. Again, these are small things, but when they're put together in community-wide ways, can have big impacts on our community. And it's another example from the California Department of Transportation. This is showing curb openings where the water drains from these curb openings, not into a stormwater system, but into a planter bed to help water and irrigate these nice amenities along the street. This is another example from Portland's Green Streets program. These are bioretention areas that again have curb cut openings to treat the water and detain it a little bit to help relieve the stormwater system. But it's done within a bulb out or a curb bump out that is also used for a traffic calming implementation. Another example of a bioretention type application. This is a medium bioswale that can be done in a roadway to capture that roadway drainage, take care of some of the pollutants, that first flush that you get of nastiness you get off of the roadway, and then kind of slow down the water and let some of it percolate into the soils if the soils can take it, and slow down the entry into the underground storm system, so avoiding flooding issues and overtaxing the storm system. Another example, this is a site application, a parking lot vegetated swell, same thing where it can take the water off the street through this flume into a vegetated swell, and that can slow the water down and provide some water quality benefits. And then here's an example. This is a project that I worked on. It's under construction now in the city of Atlanta. And this project is actually part of a bigger initiative within the city of Atlanta to create a sustainable community. The city of Atlanta is kind of unique. They still have some combined sewer systems within the city. Atlanta, as you know, is a very old community, been around a long time, and they've got these major sewer trunk lines that run through the community that carry not only wastewater but also stormwater in many areas, including where this project is located. And so when they have flood events on that combined sewer system, it's a pretty big deal for the community and creates quite a mess, as you can imagine. And so when I started this project many years ago, the mayor of the city of Atlanta at the time had a citywide initiative to create a sustainable community. And they implemented many of those LID techniques that I talked about, those examples I showed. They implemented those within the communities at the neighborhood level. The city went on a huge effort to develop permeable pavements. They didn't use the interlocking paving system like I showed the picture of, but they used actual permeable pavement that absorbs, allows the water to percolate down through the subgrade. And so they went on an extensive program of developing roadways through the city using permeable pavement. And then they did projects like this one that I had the opportunity to lead. This is a project where this area that you see, this beautiful park area that you see here, before our project happened, there was a major flood event. There was a neighborhood there. Houses, just like you see the houses surrounding it here in this rendering. And there were houses all in that area. There was a combined sewer trunk line underneath where this park is now. It was kind of an arch-shaped pipeline that measured between 90 and 100 inches in diameter, depending on how you measured it. And this pipeline got clogged and caused a major storm event, or during a major storm event, and caused a major flood. And it resulted in a FEMA buyout. So all of the houses that used to be in this area were bought out through a FEMA buyout program as a result of this combined sewer overflow flood. So my project here included rebuilding these streets to raise them up out of the floodplain, installing planters. All these street trees you see in this rendering are in street planters, like the ones I showed pictures of in the LID examples. We created a regional detention pond. Obviously, this was a low spot. Even though it had a neighborhood there, it was a low spot in the area. All the water from the Georgia Convention Center, as well as the new Mercedes-Benz football stadium and the old Georgia Dome when it was there. All of the water in that area flowed downhill to this low spot and it had flooded that neighborhood. So it was a great spot to create a regional detention pond to prevent flooding in the future. So this project included rebuilding the streets, creating this regional detention pond that was designed to accommodate a 100-year flood event. And then it also added bio-retention areas, like you see in the picture, these wetland areas. It had many, many water quality features, including the bioretention treatment as the storm pipes entered into the park. You can see different treatment options there. The fountains help to irrigate or aerate the pond to keep it healthy for the water that is there as an amenity all the time. And then we have waterfall features to again help with water quality. So it's a really great project for the city of Atlanta. And I just wanted to show this one because it's a much bigger scale project. This is a 16-acre park that is providing flood relief for a large part of the community in a major effort and as part of their sustainability and resilience plan. So the next component beyond preventing floods is informing the public. So you want to have good quality education events before a flood event. Make sure you've engaged the public. Recently, in one of the communities we work in, they had a panel of local officials at a statewide flood risk symposium event, and the question was asked. Excuse me, I have to cough. Sorry, got my voice tickled. Apologize, I'll get my voice back here. So at this at this statewide flood event, the panel was asked, what can we do differently? What should we spend more money on? Oh, I'm sorry. I'm gonna blame it on allergies here. Either that or I've been talking too much today. So, so the concern here is the public, if the public doesn't understand the flood risks, then they're not going to be prepared, if that makes sense. So people need to to understand the risk. They need to know how to access FEMA flood maps to see if their house, if their neighborhood is within a floodplain area, and they should have access to data like like we have available to us and through agencies like the USGS that can provide data to us during a flood event, so we can see how these floods are occurring and if we might be in jeopardy. So sharing this information, making it available to the public is an important part of the process, as well as warning systems. It's very important to have physical warning systems where we know that we have flood risk, so that we avoid loss of life type issues. And then next, let's talk a little bit about maintenance, the maintenance component. If you have storm systems in your community that look like these, they're probably not real terribly effective during a major flood event. We have storm drain lines caving in, structures lost, erosion happening, filling in those storm drain systems, preventing them from carrying the capacity of water that they need to carry. So having a robust asset management program is very important, and it's a very critical part to this resiliency issue. And then next, let's talk a little bit about reducing the risk. So to reduce the risk, we have to do some planning. We need to have a vision for where we want to go, a plan for what we're trying to achieve, strategy, and really targeted approaches. So there are great models out there that we can use. And like I showed you the Wichita Falls model, if you do a stormwater master plan for your community, you have a great model to build your foundation off of. It'll tell you where your flood risk areas are and provide the basis for making system-wide improvements to help reduce those risks. There's also great tools out using 2D technology, or this is a what we call a rain-on mesh grid that will show us when a flooding event occurs in this water body and where the properties are that'll be inundated and what that will look like, how the water will flow through the area. And then with all of those models and the mapping, engineers can target key areas where floodplain improvements, flood system, stormwater system improvements are needed and put together targeted plans. So that's the goal, and that's kind of the process. And so going back to Oklahoma and our situation here, I was talking about droughts and floods in Oklahoma. Well, we are currently embarking upon a comprehensive statewide water and flood program here in Oklahoma. We're set up for it well. Our last flood, our last statewide water plan, comprehensive water plan, was done 8 years ago. And it was done by watershed, which makes it really nice to be able to combine water planning and flood planning. And the flip side of that is Texas. I worked in Texas for about 20 years. In Texas, they do their water planning based on political boundaries. And so they do it kind of like by county and draw these their water planning areas using those political boundaries, which makes some sense from a water supply standpoint, but it doesn't make sense if you're trying to apply that to a flood planning standpoint. So in Oklahoma, we're a little bit better set up by the way we set up our water plan by watershed. And so we're currently just started working to help the state update the water plan, and now we're adding in the flood component to that. And the vision of the state flood plan is to develop a integrated water flood plan that raises risk awareness, motivates actions to reduce flood risk in our communities, and serves as a roadmap for long-term recovery and resilience. So I'm really hoping to get these communities in our state engaged in this activity of identifying flood risks, developing infrastructure plans to help drive improvements and help our communities be more resilient to the concerns and questions of the day. So as we look forward to steps that need to be taken here in our communities, we need to build measures into our current infrastructure projects. A project that you may be working on may have the opportunity for you to plan and design and budget for an additional element that will help that particular piece of infrastructure be more resilient to drought, flood, or whatever the disaster of the day happens to be. And we can also look at rehabbing and retrofitting projects, same thing, plan, design, budget for those improvements in our existing systems to get them retrofitted. And we can look at funding resilient measures in our current CIPs. If you're a city engineer or you work with communities, most of them have capital improvement plans and that they operate off of. And so just adding the sustainability and resiliency mindset and component to that capital improvement planning can help to get the funding of these measures incorporated into those existing programs. And there's also grant funding and financial assistance programs available in many of our communities for these efforts. And there's many at the federal level through FEMA and HUD and other agencies, and there's also many that comes, is administered through the state through our water revolving funds and things like that that can be used to help with many of these resilience measures. There are, of course, barriers out there to thinking through this and working through this thought process of planning sustainable and resilient infrastructure. One of those is if it's not visible and tangible, it's difficult to get buy-in from stakeholders. It's kind of like that hydrological cycle, talking about long-range water planning when our reservoirs are full and there's plenty of water available is not always the easiest thing to do. And same with talking about why we need to do stormwater master planning and flood mitigation projects when it's not raining and there's no issues. And it can be a challenge for sure. So it's definitely something to be aware of and to capitalize on those opportunities when we have them or when we see them in neighboring communities to get that buy-in. And post-disaster aid can produce more political capital. I mean, our politicians love getting out there, doing the helicopter tours, or getting out there and getting the PR on how they helped a community recover from a disaster. And so those kind of post-disaster efforts often get a lot more publicity and people bring money to the table than long-term mitigation measures sometimes get. And so it's unfortunate, but it's something that we as an engineering community and working with our planners really need to help work on. And then lastly there, it's necessary to get disaster recovery work done, but mitigation efforts are not always seen as the highest and best use of limited funds. If you have limited funds, FEMA has limited funds, all of our organizations do, and they've got to take care of the disasters. We had just last week in Oklahoma, we had a big ice storm, 3 different kind of waves of storms roll through and caused major issues to our power infrastructure. All of the leaves were still on the trees. And so when the ice hit, it just, snapped our trees off, took down power lines with it. We still have people today, almost 2 weeks later, 2 full weeks later that don't have power. And so all of the efforts are being spent on that disaster recovery. Everybody is out getting those trees cleared, getting that power service back, and rightly so. But as the time and money is being spent on those efforts, it's not being spent on long-term use mitigation efforts and those kinds of things. If you talk to people, like in that case, for instance, that, had a tree limb fall and knock down a power line, well, if the trees had been trimmed properly, if they were planted in the right place, in the first place, away from the power lines, we wouldn't have had this issue, and we could have avoided it, could have minimized the impacts. But instead of the money being spent and keeping the trees trimmed and programs to help our communities and our residents understand where not to plant power lines, the money is spent on disaster recovery. So it's just kind of a reality of the world we live in. So as I conclude the presentation today, just leave you with a couple of thoughts. It's hard to predict if we're going to be in drought or flood. Both are possible, and both likely will happen in our communities. So we have to constantly plan for both and to absorb and recover, to absorb them and to recover from them both. So how do we do that? We talked about comprehensive plans, looking at our communities at that comprehensive way, and planning for the future. We talked about low impact design efforts and how those can help our communities, and municipal policies and ordinances that need to be in place to set those high standards and drive good, high quality decision making within our cities, and that can help our communities be prepared. And then, of course, having a good engineer on staff or a good consulting engineer to help you prepare these plans and put the models in place and to recover from and mitigate future disasters is certainly important. So with that, that's the end of my slideshow here, and we can see if we have any questions or comments from the audience. I guess you can type them in the chat, and I'll take a look, see if anybody has any.
Yep, absolutely. We do have a couple of questions that I have over here. The first one says, would you mind explaining real-time floodplain delineations?
Okay, I'll give you my my not layman's term, but an engineer, but not like one that does that every day. But so what we were able to do during Hurricane Harvey, and also in some of the hurricanes that have hit the East Coast, is using if you have a floodplain model, so like if your community has done a stormwater master plan and that kind of exercise, or a watershed plan, they're going to have a really nice floodplain model, a HECRAS model, a terrain model, that goes with it, that they use to predict those design storms and look at their infrastructure plans. So if you have that model, we can layer on top of that and run scenarios with rain events. And so like during Hurricane Harvey, that thing was going on for so long over that period of 5 days or so, and that we were getting weather rainfall predictions from NOAA coming in, and we were able to input those into our model and predict what reservoirs were getting ready to be overtopped, so that they knew where to release water and to avoid catastrophic damage, and help try to control the release of water. And so all of that was happening. Our guys were at my company, and we're working in conjunction with many of our clients, working 24/7, all night long, running models, sending information back to the communities that control those reservoirs, so that they could take care of those releases and those kinds of things. So when we say real-time stormwater modeling and floodplain delineation, that's what we're talking about, is predicting and taking that rainfall data as it's happening and plugging it into the model, seeing where the water is going to go, and helping them. Also, an example of that also happened in South Carolina. I think it was during Hurricane Andrew. I may have the name wrong, but in South Carolina, the DOT hired us to do some modeling like that. And they the DOT doesn't control reservoirs, so they weren't using it for that, but they were using it to figure out which roads they needed to close. And because rather than just going out there and randomly putting up barriers or putting them up where they might have happened the last time, and we were able to show them specifically which roads were going to be inundated and impassable, so they could set up barriers and detour routes to avoid people driving into flooded waters. So that's some examples.
So the next question is, given weather records do not reflect the impacts of climate change, what should be used as a basis of design?
I think that's a great question. The models that our stormwater engineers use are have been updated for large part of the country and are in the process of being updated. So we do have better data today than we had a couple of years ago, and so that process is ongoing and is driving some different decisions to be made in different localities. But I think if you do some reading or go to some conferences where the sustainability folks, people that specialize in that area, gather, you'll hear them talk about concepts instead of just using historical rainfall data and to plan our stormwater systems like all of us were trained to do and going through engineering school. Instead of just doing that approach, to also look at some scenario type planning and to look, like I mentioned, like contingency plans, what if scenarios, running some different things that are above and beyond what the models and the analysis, the records are currently showing, just to see what would happen. And so if you can build in some of that kind of scenario planning and do some testing, then you can take kind of a risk management type approach to it to determine if if you think it's something that is worth spending the extra money on or not. So, and that's generally the approach that I've seen recommended, is using the historical data, but also doing some scenario planning for some extreme events and to see what it might look like, and then using a risk management approach to determine how to proceed.
So it looks as though it might be our last question, Tricia. I'd like to thank you so much for your time today and for such a wonderful presentation. Thank you so much to our attendees for joining us today. I'd like to remind everybody to take the quiz that was made available by Monday so I can get those certificates out quickly. Have a safe and wonderful rest of your weekend, everyone.